The reason I'm doing these videos on the Beirut explosion is because of this anomaly right here. Um, I've been able to look at it closer since my last videos with a different video from a view out in the port from a ship. And it offers a lot more detail of what's going on in the explosion, and we can determine that this vapor that's coming up right here was not created by the above ground shock wave. This video will also locate, uh, we're going to get real close on the location of where this is at. But this appeared before the shock wave hit it. Now, in an explosion, the only source of vapor is from the shock wave itself. So that's a real anomaly there, and it's what I call the clue that everyone missed. Uh, but to me, it stands out like a sore thumb. Uh, you don't see any other vapor around anywhere. That's the only place it's coming up, and that's not normal. But I've got a lot of material to cover, and I'm going to try to go through it as fast as I can to keep this video short as I can. So let's first of all look at the video that I'm going to be analyzing here. Now I've got it slowed down to 1/4 speed so you can get an idea of what's going on there. Just look at it for a couple times, see what it does. There's a real anomaly in there if you can't see it. All right, we're going to analyze that frame by frame. But before we do, uh, let's get familiar with how vapor forms in an explosion. This is a 500 tons of TNT, a conventional explosion. I chose it because it's got a very benign environment. There's not much blocking the explosion in any way. So we're going to go frame by frame and look at it. There's the initial flash, fireball developing. More. No vapor yet. Still no vapor. No vapor. No vapor. There. That's the first sign of vapor. Now, what's important to note is that it starts far out from the center. You know, this is at least a couple of 100 yards out from the center here, and it's relatively even. You got some on both sides. There's probably some here coming up that we just can't see because of the brightness of the flash. But it's important to note that it begins far out from the center, and it begins at the ground with very thin wisps of vapor or cloud, and then grows up from there. It thickens at the bottom and then grows up, as you'll see in the next frame. See that? Now, the only source of water vapor from an explosion is at the edge of the shock wave. There's no other place it's going to form. The reason it forms is because the shock wave compresses the air in front of it, making it high pressure. And immediately behind the shock wave is low pressure, where the water molecules behind it reach the dew point and condense into a cloud. And it's a very thin cloud because it re-evaporates very quickly behind the shock wave as the air pressure equalizes. So it's just a very thin shell of a cloud that comes up around it. Again, we have fairly even distribution on both sides. That's further behind it, I believe. We still don't really see any in here, and I'm assuming that's because of the brightness again of the fireball, that we can't see it. But it starts at the ground with thin wisps and then starts building up until it makes a dome. You can see now that there's plenty of vapor in front of this fireball. You can see how it's changed color and gotten a little dimmer in there. But it's very consistent around the perimeter. It creates the dome. That's called the Wilson cloud, is the name of it. And it's taking water vapor from water molecules that are in the air. And the reason that it takes a certain distance before they start showing up is because there has to be enough water molecules collect behind this shock wave to create the vapor. It builds the dome, and then you'll see it start rising and evaporate very quickly. But it's a very thin shell of a cloud that comes up. Let's look at a different view of the Beirut explosion. And again, we have this one spot right here where we see vapor. We don't see it anywhere else. That's the only place. This continues to develop. And we still, for all practical purposes, we don't see any other vapor. That's highly abnormal. There should at least be, on the other side, a wisp of some evidence of vapor forming on the other side of it. There's nothing. We don't really see any vapor forming until we get here. You can see. Look at the vertical lines on the grain elevators. They're dimmer here. They're getting covered with vapor. So we know here that vapor has come out behind the grain elevators closer to the camera. The actual first sign, and we're going to get to this in another segment, is right in here. That's the first sign of vapor from the ground shock wave. I'll explain that a little better later on. But this is really an anomaly to have this big, huge cloud of vapor coming up on one side only when we're just barely starting to see vapor form from the ground shock wave. Now let's go back to the video and look at it frame by frame. All right. There's the first flash. Now this establishes the center of the blast right here. The center of this flash is the center of the blast on this line. Dead center right there. Now this, to me, this is odd. I don't understand it, but this fire flashes out way to the left. We can't completely see. This is very much a foreground building right here. That's not close to the explosion. So we can't really see behind it that well, but to me it's funny that it comes out that far and then it goes back in. This right here is the first part of the fireball that we can see going up. Now, our sight of the fireball is blocked. by this shape right here. You're going to see this becomes like a mushroom shape. It's already started. That's the very center of the blast. And I'm assuming that's like very low pressure little area right there is why it's forming that shape. And I think that it's collected the smoke that was already in the area and trapped it into that shape right there. Now, this here is also smoke that was in the area. So we've just got a little gap of visibility between those two areas of smoke in order to see what this fire is doing. Now, watch this and watch this edge right here. This is the edge of the smoke. Watch both of those as we advance. See how the fire started leaning outward? Now look at the edge here. It's starting to lean outward now. Leaning outward more. We're very fortunate in this video to have two references to be able to see the shock wave. This is smoke being pushed by the shock wave. This is the edge of the shock wave. And that's what this video does for us. It shows us the shock wave very clearly that we can't see in other videos. We can see exactly what's happening. That's the edge of it. Look how it's forming a line that's tilted outward from the blast. You can see it as it advances. See how that's leaning outward? It's leaning way out right there. That's the edge of the shock wave. Okay, let's go forward. Now, this mushroom cloud is growing outward, but it's still centered right where the center of the blast was, right there. Now, this is the first sign of water vapor, right here. Now, make a note of this structure right here in the foreground, and this dark line right here, and this vapor comes up right to the left of this dark line. That's going to be important to note later. That's the beginning of it right there. But something to notice. I'm going to back up a frame. Look at the shape of the shock wave. It's leaning outward. The vapor comes up and it shoots inward toward the explosion. Go to the next frame. That vapor forms a dome. That dome isn't leaning out. It's leaning in, and then a very short top to it. It's not very tall. And it's definitely leaning inward. You can still see an edge of the shock wave out here. It's leaning outward. This doesn't comport with the shock wave. Now what happened? Look, let's go back one. You can see the mushroom shape in the center. Now the shock wave is coming directly at the camera. You can't see it because vapor hasn't formed on it yet. Remember, it takes time. It has to get away from the center and collect enough water molecules to form the vapor. And now what happens? All of a sudden now that mushroom shape is hidden behind this white. It's just starting. The shock wave is just starting to vaporize. You can see it come out over here on this side of that original dome. Here, the original dome shape is still here. It's been distorted. You can tell it no longer has that sharp low spot to it. It's been pushed out at the top. You can still make out the line of it, but look at the shape of the actual shock wave. It's going out and up. This dome is going in and up towards the center of the blast. Those two are different. Now, some people would say that this is the beginning of that Wilson cloud. Well, there's several things. We've already seen that the Wilson cloud develops kind of equally all the way around. Well, this is the only place we see it. Plus, the shock wave is the fastest moving part of the explosion. Once you can see the shock wave defined, there's nothing behind it that can catch it. Nothing. It's moving faster than everything else behind it. So if this were the origins of the Wilson dome, it would maintain that shape and just simply grow larger. But it would maintain that shape. It doesn't. The shape gets distorted. I'm going to play this back and forth kind of quick so you can see how that shock wave is coming out and slamming into that. See that? Shock wave is coming out and slamming into that dome. Now the shock wave is much more visible, and you can see that it has progressed about halfway through that dome. You can see the shape going out and up. This shape is still, you can make out going up and in, but you remember the original shape, up and in. That's a completely different shape than that of the shock wave. You can still see now the shock wave has come out. This one's still coming directly toward the camera here. This one's going out to the right. That's why you can see the edge on it. And you can still make out the shape of that original dome. The shock wave has almost come to the outer edge of that dome. Not quite there, but it does in the next frame. Now it's fully engulfed, or just about. And remember, I mean, you can still make out that original dome here. Remember, it originated right here. Back it up one, and you can see it's a little brighter right there. It looks to me like that vapor is still coming up in that location, because it stays a little brighter all throughout this, particularly right here in this frame. It stays a little brighter. So this is key visual evidence that shows that original vapor was not created by the shock wave, because here it is, and the shock wave hasn't got to it yet. We know that by the shape. Now, for your reference, I've broken down this by frame. So if you want to pause it and come back and study frame by frame, you can. But you can see the shock wave starting, coming out, out further, and then the vapor starts there. And I go on from there to whoops, I didn't get that centered. Frames 12 through 16. I've got them labeled so you can study them. So if you want to stop the video, just for me to save time on the video, you can stop the video. and take a look. I've also got a link to the video from the ship if you want to pull it up and do some stop frame work on that, taking a look at it closer. Now, in order to do any study uh, of this and try to locate the origin of that vapor, I had to get a sight line. It was fairly easy to do. This is frame 2, and we're very fortunate that this fireball that shot out this way reflected off of the grain silos, which are this little square area right here is the grain silo. I was confused at first because I thought this was the grain silo, but that's too tall. That's not it. It's this little square area right here, and this is the far left edge right there. So the center of the blast is just a little to the left of the left edge of the grain silo. So this was pretty simple to just draw a line through the center of the blast, just to the left of the grain silos, and that establishes my sight line. I know that this vapor in question originated right here. That's where the first jet came up, and it was located to the right of the center of the blast. So we know for a fact. Now, I just drew this in just kind of roughly for a quick reference, but we know that the vapor in question is just to the right of the sight line, somewhere along this line right here. That we know is fact. So our next challenge is to find out how far away from the center it is. Once we can determine that, we can draw the circle, and where the circle and this line intersect is where it's located at. My next step was to determine the time that is involved. So I loaded it up on a piece of software that gives me the time breakdown. And from frame 1 with the first flash, we're at 10.62 seconds. At the frame 15, and I chose frame 15 because that seems to be about where the shock wave is getting real close to this point where the vapor first originated. It's almost right there. Okay, so it took 40.47 seconds for the shock wave to travel from frame 1 to frame 15. Now, first of all, that's very close to half a second, so that confirms that we're dealing with a 30 frame per second camera, which is standard. Now, this shock waves supposedly travel at about 340 meters per second. This number is somewhat in question. I've seen some reports that 370 is the number. I've seen reports that show the rate of travel of the shock wave varies depending on atmospheric conditions, type of explosive, etc., etc. But 340 seems to be the number that this type of explosion travels at. But due to the fact that it's not totally clear, we need to try to find out how fast this Beirut explosion shock wave was traveling. But at frame 15, according to this, the shock wave is 159.8 meters out from the center of the explosion. Now that's if this number is good. So now we have to take a look and see if that number is good. So here's what we did. First of all, I found this map. Now, in order to determine if that 340 is a good number, I need a measuring point of where the vapor appears, because again, the vapor defines the shock wave, and try to get a sense there. Now, this map, each one of these little blocks right here is 100 meters. I drew a circle out here of 150 meters, just as a reference point, because that's just a nice clean number. It's a 150 meter radius. This over here is the grain silos. Now, I was confused at first because this map didn't actually show the silos. I drew this red in right here. This map only shows the site that the silos were on. You can tell when you come over here and look at the actual photo, you can see the site the site boundary comes down here, slants in, just like this over here slants in, goes across, down, and out this way. This bottom line of the site right here is almost an extension of this dock line right here. It's just up a little bit, and you can see that if you extend this dock line down, it's quite a ways removed from the far end of the silos. So I just estimated visually from this line to the bottom of the silos, just proportionately, what it looks like on its site. And I put the back line of the silos right there. I think you'll agree that's pretty close. And mainly because this back edge of the silo is really about the only thing we've got as a reference point to measure from the center of the blast. Now, it is right at 125 meters from the center. Okay, that's something that we know to go by. So the thing to do now is to find out when we first start seeing vapor accumulate on the back edge of the silo. So we know that that this back edge of the silo is close to 125 meters from the center of the blast. Now, the first sign that I can find of vapor is this corner right here. Now, I can't tell if that's peeking out around the corner or if that's actually out here covering this. In frame 12, it's clear to me that this little bit of vapor is out here right about on this side of the silos. There's a few clues to it. Number one, look at this little gray strip right here. All right, in the next frame it turns white. That's because vapor is forming there, and you can see that the lines on this are getting dimmer. They get noticeably dimmer over here, and you can see this vapor that's formed on this corner has now definitely come out well in front of the silo. The difference between 10 and 11 in that shape tells me that at 11 this this little bit of vapor is right about dead even with this side of the grain elevators. So I think it's fair to say that the first sign of vapor on this side of the grain elevators is either frames 11 or 12. And we know this is 125 meters roughly from the center. That's consistent with 340 meters per second for the rate of travel of the shock wave. If you notice frame 11, 124.3 meters based on a 30 frame per second camera, because each frame it moves 11.3 meters. Frame 12, 135. So we're definitely in the ballpark of 340. I think that's a fairly accurate measurement. So in frame 15, we know within reason that the shock wave has traveled 169.5 meters, and that's fairly close. And in frame 15, we can see again, you can still see the dome. This is the shock wave over here on this side of it, and the shock wave over here on the left side of it. And that it's almost fully engulfed that original dome. So it's almost even with this original source right here where it came out at. So we're at 169.5 meters out from the center right there. So let's go back now and look at this. I've got this actually just a little bit too far in. It should be out right about where the tip of my cursor is, right there. So I'm pretty close to the center there. Because again, we know that it's on this side of the sight line, and we know that it's about 169, give or take, somewhere in that vicinity, out from the center of the blast, and that puts it right here in this location, right here. Now, what's interesting about this is this. This is the general location right here of the vapor. It's sitting right on top of what appears to be deeper water, a deep hole right there. Now, darker water basically it can be any one of three things. It's either deeper water, it's seaweed. Seaweed usually has a black color to it, at least where I'm from. But seaweed can make it darker, or clouds. I don't see any clouds in the area. Doesn't look like seaweed to me. All it can be is deeper water. This looks like a deep hole in here. And it looks like it kind of blew out all the way around. You can see the way it appears that it's sloping downward to that dark water right there. So what we know as fact is the vapor column in question originated right over this dark water area, and it came up ahead of the shock wave. It was not created by the ground shock wave coming out. So I can't factually say, but it looks like, and it's my opinion that what happened is the explosion was here, and it had to travel underground in some form or fashion and come up just a fraction of a second before the shock wave hit it, because we know it appeared before the shock wave got to it. It was not formed by the above ground shock wave. Now what's interesting is we've got apparent dark water here too, very irregular shape, like like this was blown out. We've got darker water here that looks like it's going underneath the pier structure. And this dark water here appears to continue on this side of the pier over here. Another, I can't explain it. I don't know. I can't say. But another interesting thing is if you draw a line in the middle of this shape through the center of the blast over to the middle of this darker water shape, right directly in line is this building that was on fire. And I never could understand how that fire got started because it was shielded uh, by the grain elevators right here. It was behind it. So that's kind of an anomaly too, which I'm not going to be able to research. My main thing was I knew that this water vapor was very odd, the way it came up. It wasn't consistent with what we can see in other explosions. And now we know as fact that it came up in this location and it came up prior to the ground above ground shock wave hitting it. The rest of it you'll have to answer for yourself. Thank you very much for watching.